Our topic for today is natural logarithms, 7.6. Our objective for today is to solve natural logarithmic equations, as well as condense and expand natural log expressions using the properties of natural logs. It's a long-winded way of saying that we're going to be doing the same thing we've been doing the last two classes, but specifically with what's called a natural log. We'll go over what that is in a little bit. This will be demonstrated on the exit ticket, the quiz, and then the final. I want to remind everybody that we have a quiz that is due tonight by midnight. If you have not completed that, it was assigned on Wednesday. Make sure you complete that as soon as possible. I'd like to remind everybody that we're coming up on the end of the year. This will actually be our last new subject of the year. Next week, we will go into what's called map testing. We did that at the beginning or at the middle of semester one, kind of later in the year. We're going to be doing that. And then we're going to go into our week of review, and then we'll take our finals the following week. Which also means that if you are currently not where you want to be with your grade, you definitely need to start, turning in that late work because there's not a lot of future points on the board. About it for what I have. Yeah. So remember, this is the last notes that we're really going to take. The rest is all going to be review or testing. Wanted to let everybody know. So we're going to go over what's called a logarithmic function, specifically my natural logarithm. It follows the same properties as before. We're going to use those properties down below. First section we're going to go over is condensing natural logarithms, just like we've been condensing before. Then we're going to go into expanding natural logarithms, get a little refresher on how to do that. Then we're going to go into kind of our newer section where we're going to be solving e to the x equations. And then we're going to go into finally solving natural logarithmic functions. Those are the four topics we're going to go over. Once we're done with all of those, and we've done the you do problems at the bottom, we're going to complete the exit ticket. The exit ticket's how you get out of class. Make sure you complete that before you leave. It is how the school does attendance. So let's go back up to the top where it says logarithmic functions. We're going to go over what is a natural log. First thing I want to do is this was not big enough in my last class, so I need it much bigger. So now we can see. So we're going to be talking about today. Insert. I think 24 was too big actually. I think 20 is what actually fit everything. So a natural log is a specific thing we call Ln. That's an L, that's an N. Natural log, which is really just equal to a regular log with a specific base of E. Now, if you remember back to the beginning of our unit, we talked about E a little bit. E is just like pi, where pi is just some number that comes up very frequently with circles, and so we gave it a symbol for it. We did the same thing with E. E comes up a lot in a lot of our natural things in our lives, like the spiral of a pineapple or how a pine cone spirals as well. We'll say pine. It's funny. So we call it a natural number. All right. That's why we call this the natural log, because it's the log of the natural number. So that's really, we're just meant to make this simple. Another time this type of thing comes up with natural logs is when we're talking about how prescription drugs work in your system. They follow a natural logarithm where they slowly dissipate in your system, take some time to get into it, all that type of stuff. All right. So if you are planning to become a doctor at any point, if that's one of your goals in life, you'll be using a lot of natural logs throughout it to kind of see how the body works. We specifically have a special symbol for natural log because we don't want to have to write out log base E every time. Right? So we made a symbol like this. Now that symbol is on our calculator, and so we can just type in Ln without having to do our change of base formula and everything. It's tough. All right. So hopefully that makes sense. Oh, that's good stuff. That's what a natural log is. Before we move into our actual lesson, does anybody have any questions on what a natural log is? All right, or my little e is, my natural number e. Anybody have any questions on any of that? Right, I don't see any questions in the chat, so we're going to move on. The properties of a natural log are the exact same as my regular properties. My product property still acts the same whenever I have multiplication. It changes to two separate natural logs with addition in between. Whenever I have division, it turns into a minus sign with two natural logs between them. And then power property, I take the exponent and I put it out front, or vice versa. We can go the opposite way as well. From a positive to putting them together to be just multiplication. All depending on what we're asked to do, whether condensing or expanding. So let's go over this now. This first problem right here, 2 natural log 15 minus the natural log of 75. When I'm combining these, I'm trying to put them together, I need to have no numbers out front. Right? So for me to be able to combine the ln and this ln right here, these natural logs, I need to get this 2 away first. To do that, I use my power property. So I get the natural log of 15 squared minus the natural log of 75. That is my power property. Moving that 2 from out front up to my exponent. I'm going to follow that up with a little bit of my quotient property, since I see there's this minus sign in between. There's nothing out front. I can combine these two, and I will get this right here. Natural log of 15 squared over 75. Now again, I use my quotient property for that. And then I did some simplifying. 15 squared is 225. Divided by 75 is 3. So my final answer will be natural log of 3, which we can plug into our calculator and get this as our answer. Right. So we end up with 1.10. That's pretty close to our answer. Before I show you how to plug it into your calculator, are there any questions on any of this process that we went through? Either using our power property, our quotient property, or anything else? Yeah, I can go over it again. Yeah. So again, this is asking us to condense our natural logarithms right here. So right here, what I'm trying to do is put this whole thing together. To do that, I need to move this 2 out from out front. To do that, I'm going to move it up top using my power property. So now it's 15 squared right here, minus natural log of 75. So that stayed the same. Once we had this right here with 2 natural logs that are right next to each other, I can use my quotient property. Since this is a minus sign in between, I know it's going to be division. If it had been a plus sign like over here, it'll be multiplication. So I'm just doing the opposite. 15 squared over 75. So what we get when we combine these using our quotient property. Then we just do some simplification. My 15 squared is equal to 225. 225 divided by 75 is just 3. That's how we get our answer right there. Then we plug it into our calculator like so. We go drunk since that looks weird. We can either type ln and then put in whatever number, like so, or we can go over to where it says functions, and we can click the button that says ln right here. We can type in 3 as well. And to make it look nice, you end your parentheses. All right, nice and easy that way. Again, I can just type in ln, or I have an ln button somewhere. Are there any questions on how I plugged in the calculator or anything else we've gone over so far for this first one? Right. Let's go over the next one then. Same type of process. From here to here, I like to simplify the inside of parentheses first. Now what you're going to find is there's a lot of ways to do this problem in different order. But really we're doing the same thing every time, no matter what we're doing. I like to simplify inside parentheses and then multiply by anything on the outside. Some people like to distribute it in. Whatever you like to do, you can do. You'll find a way that works for you, and then you'll do it that way. My way of doing it is I move it up top because I like to simplify here. So that's going to be my power property. Once I have both of these natural logs right here as two separate natural logs with nothing out front, I can now combine them. So these become 3 times the natural log of xy squared plus the natural log of 5. Again, that right there was my product property, because I changed this plus sign right here into a multiplication sign with one natural log. Now I can move this 3 up top over here and make this something that looks like this. Again, that right there would be my power property. So I took that number that was out front and I moved it to as an exponent. Now, for me to be able to combine these two, I kind of got to simplify this right here. So I'm going to shower the power so that I can get this answer to be a little bit nicer. So this process of throwing the 3 to this one, the x and this squared, that's called shower the power. There's some other names too, distribute the power, whatever you want to call it. Now that they're all kind of by themselves right here, I don't have any more parentheses and combine these much easier. Since this is a plus sign, I'm going to multiply. I end up with natural log of 5 times x cubed, y to the 6th. That right there is my product property. I want to remind everybody there are other ways to do this. I could have distributed it into 3 right away and then done some other math. Maybe it would have been easier, maybe it would have been harder. All depends on how you kind of think. You'll find your way of doing it. Are there any questions on this process I just went through for either of these two problems before I set you loose to work on this you do problem right here? Anybody need me to explain anything, go back over it, anything at all? That's a great question. Someone asked that same question last class. So someone asked in the chat, in the third step, why did you take the ln out of the parentheses? I did not take the ln out of the parentheses. I actually got rid of these parentheses right here, really. The reason we have, so I took this right here and I put it up top. This whole thing is inside of my ln. My ln isn't a separate thing. It's like housing all of these things. Right? It's like when we have, it's another good example. It's like when we have a square root. inside of a square root, we have everything inside of it, and then we end it at some point. This is me saying that all of this is inside of my natural log. It's like being inside of a house. It's one of their rules. So when you're doing this, this isn't being pulled out front of the parentheses. This is saying that before just the xy squared was inside the natural log, but now I pulled the 3 inside of my natural log and made it a cube. So this would be my answer. Does that make sense? Or do you want me to explain some more? I'm going to set everybody loose to work on this one right here. I'm going to put 2 minutes on the clock. I'm going to see what we can do. So you have 2 minutes starting now. Let me know if you have any questions. As always, I'm here to help. Who can explain to me? Let's start with this. What is my final answer? What should my final answer be for this one? Who can tell me? Things I got to guess for. I'll tell you this. It starts with a natural log. Yeah. Perfect. Almost perfect. It's ACB. I'm going to put a 2 for each one just because that's how I like to put it. But if you put them all in parentheses and put a power of 2, completely okay with it. Nope, that didn't work. Squared. Very close. ln. That's correct. All right, let's go through our steps to get there. That's our final answer. That's what we're trying to get in the end. Let's go through it. What was someone's first step? Someone tell me what they did first. Yeah. Ooh, that would actually be something that would be technically incorrect. But it could technically work as long as you did it right. But remember, I always go from my left to my right. What should I do first before I combine the B and the C? Sure, we can do that. We can distribute the 2 first. It's a completely legitimate thing that we can do. New equation. We can get 2 ln of A minus 2 ln of B plus 2 times the ln of C. What would I do next? Got an idea. Good. So someone said power property in my chat. I forgot to actually put this, what we did here. This would be my distribution property. And someone said power property, so let's do that. Power prop. Let's show what that does. I end up with new equation, ln of A, I like it with that space. I think it looks a little nicer. Squared minus the ln of B squared plus the ln of C squared. Right. Perfectly done with my power property. Distribution. What would I do next? think they got it. Thinks they know what we do next. It'll be ln of something, I'll tell you that. All right, I'll give you guys a hint. It has something to do with this minus sign right here. What does this minus sign tell us that we need to do? Divide, right? What's that called? What's that property called? I don't think I heard. Perfect. I'm going to use my quotient property right here. I'm going to divide these two numbers because there's a minus sign. And I'm going to get a squared divided by b squared plus natural log of c squared. I like that space there. I think it looks nice. Again, that is my quotient property. Now I actually don't need another space because the next line actually figures right into it by using my product property. Get my final answer. Now again, like I said before, there are different ways you could have done this. You didn't have to do distribution property right away. You could have combined all three of these using the quotient and product property, and then use your power property and then distributed some exponents. That would have worked as well. Again, it's however you decide to do it. As long as you have this as your final answer or something very similar to this, then you are good. Are there any questions on this answer before we move on to our next section? Yeah. Yeah. You meant parentheses AC over B, right? So it should be AC over B in parentheses to the power of 2. Let me just make sure that you have this written down correctly. So you said AC over B, all parentheses to the power of 2 like this, right? You got it like this? Perfect. I wanted to make sure. So someone asked, how do we know if C goes on the top or the bottom? It's this plus sign right here. If it's a plus sign, it's going to go on the top. If it's a minus sign like this one, it's going to go on the bottom. So minus sign bottom, plus sign top. Any other questions before we move on? Yeah. No. So that's a great question right there. If you had left it as A over B times C on the outside with like all of this like this and the squared, completely fine. That is a completely fine answer as well. As long as you don't have the C in the denominator, that's when we have an error. That's when we have a problem. But as long as you have it multiplication right here, fine. You could have also had the weird version. You could have gone A times C over B as well. I've never seen that one as one of the answers for this problem, but it is technically a legitimate answer. All squared. All right. Questions? Thank you for answering, by the way. Any other questions? Great questions. All right. I didn't notice another question in the chat. Someone asked earlier, I didn't see it. Someone asked, what exactly is ln? Again, ln is equal to the log with a base of e. This right here is my natural number e, and that's what we call this the natural log. natural number, natural log. So a specific log with a specific base right here. And again, E is just a number that comes up very often in our math classes. And so we gave it a representation. It's like, I think 2.71 something, dot, 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 dot. But the actual number doesn't matter as much as the fact that it comes up so often. There's some reasons that it's even cooler than what it looks like. Some like geometric sequence stuff and stuff like that that makes it very interesting. I digress. Any other questions? All right, let's move on to our next section then. Get some more practice with this by expanding. I think expanding is a little bit easier than compressing because you don't have as much math involved. And I think that breaking it apart is a little bit easier than putting it all together. So all I'm going to do with expanding is whenever I see a multiplication, like here and here, I'm going to change that into addition. So this multiplication is going to become two separate natural logs that way, with two additions in the middle. Okay. Plus and plus, broke it up that way. Now the last thing I got to do is I have this y squared right here that has this exponent of 2. One of my expanding things I need to do is pull that 2 out front using my power property. First, let's put product prop right here, and then move that 2 out front to get my power prop. Again, I just took that 2 right up here, moved it right out front. Right there. Very simple in that way. Same type of thing over here. I have a multiplication right here, and then I have a dividing by b right here. So multiplication turns into a plus sign, division turns into a minus sign. So I will end up with the natural log of 3 plus the natural log of a minus the natural log of b. To do that, we used our product slash quotient property. Again, division turns to a minus sign, multiplication turns into a plus sign. Separate natural logs throughout. Are there any questions on either of these two answers before I set you loose to work on this problem right here? Anybody confused on anything? Anybody want me to re-go over anything? Go back from the top, anything at all? All right, I'm going to put 2 minutes on the clock. We're going to see how far we can get on this problem. Again, if you get your answer, please put your answer in the chat. I'll let you know if you're correct or not. All right, you have 2 minutes starting now. I want to remind everybody that whenever we break it up into multiplication to addition, we add a new natural log right there. And so if I break two things up, like the 3 and the a, both of them get natural logged. Same thing with this b on the backside, this one also gets its own natural log. So think about that when we're doing this problem right here. All right, that is time. Let's go over this problem now. Clear off my drawing. Let's scroll down a little bit. Let's go over this. Let's start with our final answer again. Who can tell me what my final answer should be? Yeah. Give me 1 second. You're going way too fast. I can't type that fast. All right, go. That is almost perfect. Anybody have any hint on why it could be just slightly off? Or change it just slightly to make it fully perfect. We're missing one number. Yeah. Exactly. There should also be a 3 here too, because there's parentheses around here, and so this 3 has to go to both of them. This is a perfect answer right here. Let's go through how to get this answer. Again, just like before, we were talking about the one above and how there's multiple methods that I can go about to get my answer. Same thing here. Multiple methods to be able to get this answer. Who thinks that they know our first movement? What should we do first? Now remember, there's multiple options. So there could be 3 different options right here for things to do. It's actually 2. Yeah. How would you do that? That's close. I'm thinking X and Y are multiplying so I can break apart. I can't do that yet. Why can't I? Almost. It's this 3 up here. So right now they're inside their own house right here that I can't get into just yet. The first thing I need to do is get rid of this 3. Who's got another idea? Give me another answer. That'll be perfect for later on. That'll be one of our last steps. Yeah. Slow. Give me 1 second plus ln y to the power third. Perfect. That is a correct way to do it. There is a step in right above this that I'm going to write down real quick. That doesn't, a lot of these, there's a bunch of little steps that you could do along the way where you could have gone ln 2 x cubed y cubed. And that step right there would have been my shower the power property. All right. If you did not have this on your paper on a test, something, I wouldn't mark you down. All right, this would be completely fine to be missing as long as you keep the numbers right and you distributed the 3. And then we used our product property right here. Broke them apart. What can we do now? What should we do now? I guess I actually don't even need another line. We have our answer right here. How do we go from here to here? What's that property called? And either no one's listening in the chat or we are very confused. What is the property that lets me go from natural log x cubed to 3 natural log x? What's that property called? You can tell me in the chat. I got 1 for 1 correct answer so far. Let's see if someone else can tell me as well. I want someone in the chat to tell me this time. Maybe I'm getting a lot of you guys telling me. Who else in the chat can tell me what property I use to go from this 3 up here to this out here? Good, I'm getting some more answers. I'm going to put those answers in the chat. Power property. Whenever I have an exponent and I move it out front, that's my power property. Perfect answer. And before we move on to our next section, are there any questions on this section? Any questions on anything we've done so far? Anybody confused on anything? Anybody want me to explain something? Go back over it? Anything at all? Right. Hopefully that was enough time to copy this down, all that good stuff. If you are still confused, let me know. We can always come back to this problem. What I want to do is come back up to the top where we're talking about our objectives. We just finished up our second objective right here where we are talking about condensing and expanding natural log expressions. And now we're going to move on to solving natural logarithmic equations. Right. That's what we're going to do now. Got this one done. Moving on to the second set. So now we're going to go down to where it says solving e to the x equations. This is exactly the same thing as what we did yesterday when we had something like 2 to the x, let's say, equals 40. All right, and then we rewrote it in log form to say log base 2 of 40 equals x. All right, and then we plugged that into our calculators using our change of base formula. And we got our value out. We're going to do the same process, but this time with e's. It'll be something like e to the x equals 40. We're going to rewrite that as log base e to the 40 equals x. Now, the only difference is this log base e is a special thing we call the natural log, so we're going to change that to be ln of 40. But again, I want to remind everybody, it's the same process that we did before, we did last class. We're just changing it from a 2 to the special letter e, which changes our log slightly. But it's the same process in the end. We're still plugging into our calculators to get our answer, all the same stuff. So let's do it over here. Before I can actually do this process of changing it over, I have to get the e to the x by itself. To do that, I have to get rid of this 2, and I got to get rid of this 4. Get rid of the 2, I subtract 2 from both sides. So I get 4e to the 2x equals 14. Then I divide both sides by 4. And I do some simplifying. 14 divided by 4 is equal to 7 over 2. And so now we have our equation just like we had before. Following the same pattern, we replace our 2x with this 7x on the 7 halves with the outside. We move this right here, back up top. Change the e with a natural log. I end up with 2x equals the natural log of 7 halves. Again, just replacing these two, changing this to a natural log. All right. Now that I have this right here, I've got to move the 2 away from the x, so the x by itself. So I divide both sides by 2, plug it into my calculator, and this is what I end up with. Are there any questions on this process? Anybody confused on anything we did? Anything at all? Anybody need me to repeat anything or go back over anything? Anything at all? Let's go over the second one then. Same process, got to get my e to the negative x by itself first. So I divide both sides by 2. And I get e to the negative x equals 10. Now again, I want to remind everybody, the reason that we change it into this form is because I can't do anything with this exponent of negative x. All right. I can't find out what x is equal to as long as it's in this exponent thing right here. So to get it out of the exponent, we got to change it to the other form. All right, so I change it from e to the negative x equals 10 into negative x equals the natural log of 10. Now to get rid of a negative, I move it over to the other side, just like so. Plug that in all into my calculator, and I will get negative 2.3 as my answer. Now, I would like to ask, does anybody have any question on this answer right here? Anybody confused or want any explanation for this answer right here of negative 2.3? Do you have any questions before I set you loose to work on the problem down below, the you do problem? So the e and the natural log kind of replace each other because they're opposites of each other. So to get rid of this e right here, I changed it into a natural log on the other side. It's just like when we have like a x squared equals 4. To get rid of that squared term, I'm going to square root both sides because the squared is the opposite of the square. Natural log is the opposite of e, so I natural log both sides and the e goes away. It's another way to think about it. So it's getting replaced with this e right here. Flip-flopped. All right, let's go over and try that you do problem right there. Let me know if you have any questions on it. I'm here to help during this time. Let's go another 2 minutes on the clock. Let's see what we can do. You have 2 minutes starting now. As always, let me know if you have any questions. I'm here to help. So what is my first step when I'm solving this problem? John, what's my first step? Good. So I'm subtracting the 7 from 40. I'm going to go new equation. And I get e to the power of 3x still equals what? Perfect. Who can tell me the next thing I do? Yeah. Go. $37? That'll happen. I don't have to do that. Divide both sides by 3. That's what I'm going to get as my answer. Yeah. You did exactly what I do on a regular basis where you go 40 minus 7 is 37, which is a very common thing to have happen, especially when you're tired or you're not paying too much attention. It happens all the time. Any other questions on this one? Anybody confused on anything? you got a different answer and you want to know why you got that answer, let me know. I'll show you what you might have done. Anybody confused? Anybody want to? That'll do it. That'll do it. Perfect. Figuring it out. All right. I'm going to leave this up for a little bit longer, about another 10 seconds, and then we're going to move on to our last section, solving natural logarithmic functions. So again, this is another thing that we've done before. When we were solving log functions, let's say it was like log base 4 of x equals, let's make a regular number like 3. We had two different methods that I showed how to do this. One method, we rewrote this right here. We put both things to the 4th power. We canceled this out, and we got x equals 4 to the 3rd power. That's one way to do it. We can also just rewrite it in that exact form without doing the exponent part. Using my log rules, I can just flip everything, and I can say that x equals 4 to the 3rd power. Because I can always just flip-flop this number and this number right here without actually having to raise it to that power. All right. Either way works. Either way gives you the same answer in the end. Again, I can do it this way, or I can do it the way where I go log base 4 of x equals 3, and then raise both sides to that 4th power. 4 and 4. These cancel. I get x equals 4/3. 4 to the 3rd. Okay. The same type of thing is what we're going to do over here. Before we can do that, though, we have to combine this 2x and 3. So a plus sign tells us that we need to multiply. So we multiply those two together. Do a little bit of simplifying, and we end up with natural log of 6x equals 2. Now this is where it's kind of similar to what we had before. We can pick which method we want to use. We can either put both things to the e, this power right here, and these cancel out. I'm just left with 6x equals e squared. Or I can just do the rewriting process and flip-flop these two like we did before. Move the 2 over here and the 6x over here. Either way works. Again, replacing that natural log with the opposite thing, which is an e. Doing a little bit more simplifying and plugging into my calculator will give me this as my answer, 1.23. Are there any questions on that process before we move on to our next problem? Anybody confused on how I went from 2x plus natural log of 3 to 2x times 3? How I got 6x, or how I rewrote it? Or maybe even how I plugged into my calculator. Maybe you're like, man, I really don't understand how this whole plug in the calculator thing works. Yeah, so again, with the flip-flop method, all I do is I take my 6x and I move it over, and I move my 2 to the opposite side, and I change my thing to the opposite. So instead of natural log, there'll be e. So if I was going to write this out, it'd be e, this backwards. Natural log of 6x equals 2. I think it's a little bit easier when we rewrite it kind of like moving this over, changing this natural log to an e. So this natural log becomes an e. This 2 got moved over, so I get e squared equals, that's not a good equals, 6x. All right, so my natural log always switches over to the opposite one. Same thing as above when we flip-flop to the other way. I just change it to the opposite one. Any questions on that? Yeah. Sounds good. For future reference, there's also laptops you could use over there too. Anybody want me to go over anything else before we move on to the second problem? Let's move on to the second problem. This one's already combined for us, so we don't actually have to do that first couple steps. We just do the rewriting process, turn it into e squared equals x minus 3. Add 3 to both sides, and we end up with this as our answer, 10.39. Are there any questions on this answer before I set you loose to work on this you-do problem right here? Any questions anybody wants me to answer? Anything at all? All right. I'm going to put 2 minutes on the clock. Start working on it. Let me know if you have any questions. Here to help. Another way you can think about it as well. Crisscross and bring down. Ooh. What? No problem. All right. That is time, so let's go over this answer now. Clear all our drawings. We're going to go down to this one. I forgot my new equation. Anybody tell me what x should equal? Anybody tell me what they think the answer for this one should be? This one seems to stump more people than the other ones. But he got it? All right, then. Instead of going with the answer right away, let's start with the process then. And slowly get to our answer. What's my first step for this? Yeah. ln of 5x over 20. Perfect. You even said the right words with quotient property. Perfect. Quotient property. No, because of the fact that it's a minus sign in between, we have to do division. Okay. Remember that minus sign means that it's going to become division. Key point right there. Now I'm going to do some simplifying right here. ln of 5x over 20 is going to simplify to be x over 4. That's called simplifying. What do I do next? Let's try someone who hasn't talked a lot today. Who thinks they know how to rewrite this without having to write, without someone that's talked a lot today? Let's give some other people chances to talk. I think I've only had about 4 people talk today, so I can get someone else. Right, let's get someone who has talked then. Who thinks they can give it to me? You got it? Give me 1 second. I got to do my fraction bar. Take some time. X over 4 equals. Perfect. I'm going to move that 4 over, and my final answer will be. Good. I plug that into my calculator, and I will get a number that is quite large. Not the largest we've seen. 4,386.53. Are there any questions on this process? Any questions on any step that we've taken so far? Right. I'm going to leave this on the board for you all to copy down if you have not already copied it down. If you feel like you are solid and you're ready to go, you can start on that exit ticket and complete that. Once you're done with the exit ticket, you are free to go for today. Make sure you complete that before you go. And then also thank anybody, I want to thank everybody for answering any of my questions. If you did in the chat or if you talked up, that was very kind of you. It makes my job much easier. Let me know if you have any questions. Have a great day.